Hey everybody. Hey, today I'm going to talk about oil. But before we get started, first welcome to the Bits of Wisdom channel, and let me preface this with why I'm talking about oil. A lot of my topics come from comments that I get on the channel or I pick up different places. And one of them I've seen lately has been oil, particularly the new oils. You'll see like 0W20 and 0W16, and people expressing concern about using those and wanting to go back and use what they're used to, I'll call it. And there are a lot of times where people don't always have the right information, and rules of thumb from years gone by persist, and everyone's entitled to use what they want. But I've got a little explanation. I'm going to show you a few different things to look for. I'm going to show you some charts to try to explain what some of these differences are, and then we'll go from there, so you got a little more information. First of all, though, before I dig in too far, why should you listen to me in the first place? I mean, people who have been watching the channel for a while know that I've worked on a lot of different cars. I give technical information on that. I spent 38 plus years working for General Motors. Almost all of it was related to powertrain engines and transmissions in one form or another. I worked for the vehicle organization for a while, but still focused on powertrains because that was my experience. When I retired, I had been an assistant chief engineer for a number of years on hybrid powertrains. In that role, I was a systems guy. My mission in life was to bring design engineers together, development engineers together, take an engine, a transmission, electric motors, electric power electronics, and so forth, and put that all together to make it work. That's kind of where I come from. And I started my life at Allison Transmission working on what's called the X1100, which is a 5,000-pound transmission for the M1 Abrams main battle tank. And that's kind of where I got my break in, so to speak, on oil, because particularly low temperatures, because we had to the military wants you to work in extremely hot environments, and they want you to work in extremely cold environments. And we had environmental chambers to run transmissions in that went as cold as minus 65 Fahrenheit. You ever been in minus 65? That's dang cold. I worked pretty closely with a lot of the engine team people and a lot of the transmission people. Anyway, enough about me, but just so you understand, I'm not just plucking things out of air. It comes from a background. So to the first question of people who are fretting about, my car wants 0W20, should I use it or should I go back to my normal stuff? I would say don't worry about it. It's not an issue. You should use what the manufacturer specifies. Second guessing the manufacturer will get you into trouble in many cases. It may void your warranty. So you want to go to your owner's manual. You want to find what they specify and then follow that closely. Because believe me, engineers and development engineers and the chief engineer for the engine, they want their products to last. And they run thousands, tens of thousands, hundreds of thousands of hours and miles to qualify oils to work in their engine. It's not, I've seen this done. It's very rigorous. That's my starting point. But now I'm going to dig in and show you what you should be watching for, and then I'll show you some data. First of all, everybody worries the most about the SAE rating, or the weight of the oil. It's 30 weight, it's 40 weight. And those define a specific viscosity. Then you've got the API ratings, which is, like SN, SM, SQ. Those ratings are based on certain other test procedures that, the oil can meet a certain viscosity, but it has to run a bunch of other tests for wear, for cold cranking performance, for hot, there's a whole set of tests. And the latest one, this SQ, I believe it is there, is for low-speed pre-ignition in GDI and in turbo engines. So they've developed an oil spec that makes sure that doesn't happen. That's how it goes. When I started getting into cars in the late 60s, early 70s, SD, SE was where they were at. Now you're up to SQ. Then there's a starburst symbol, and that starburst symbol, it's usually on the front of the bottle. Sometimes it's in the back, and it says, this one says, American Petroleum Institute Certified for Gasoline Engines. So you generally want to have that. And again, if you go to your owner's manual, they'll tell you, what specs your oil ought to have, and it's always best to follow that to the best that you can. There's one called ILSAC, that is, usually it's a GF number, GF4, GF5, GF6. This mobile one that I've got in front of me is a GF6A, actually. And that's another specification that they meet. And then if you're into General Motors, and some other companies may leverage this, but there's this Dexos, or Dexos, depending on how you want to pronounce it, DEXOS, that was developed some years ago by General Motors because, when I was working there, we were concerned because the standard specifications didn't ensure quality in every oil. You could buy oils that we would put in our engines that didn't perform well. And so we wanted a tighter specification. And we've been using that for years with Dexron, right? You go back to Dexron, I don't remember when it started, probably the 60s, before my time working on cars. But you had Dexron, then you had Dexron 2 in the 80s, Dexron 3, we're up to Dexron 6, but it's a specific set of specifications that ensures that a fluid that's licensed to that will work in the applications that GM specifies it for. And so today for gas engines, it's Dexos 1 Gen 3, and then there's a Dexos R, and then there's one for diesels. And if you go on the internet, you can go look up, go do a search engine, look up for Dexos. You'll find the definitions, you'll find a list of what oils are certified to each one of the specs. And again, if you go to your owner's manual for a GM car, you'll find these things described. Now, I'm going to stop for a second here, and I'm going to show you a little closer. I've got some bottles. You can't see them in the camera right now. But I'm going to show you what these look like on the bottles and give you a little explanation of that. So let's take a look at some of these oils. I've got a few examples here, and let's just see what I'm talking about. Here's a Valvoline 30 weight. This is old school oil. This is the one I use in old air-cooled lawnmowers and stuff from the 80s, 90s, and so forth. 30 weight oil. This one's Service API SN, right there. It says it exceeds API SN and SM. And these are a little older. Well, this bottle's probably been on my shelf a couple of years. I don't use it as often. I just have to keep some of my old engines running with that, the old air-cooled ones. What you'll notice is that it doesn't have other things noted on the bottle. Here, let me show you in a minute. Here's Valvoline 5W30 conventional, and again, this bottle, it's been on my shelf several years. The cars that I have don't use this anymore, but the point to be is, so this one has the starburst symbol for API, American Petroleum Institute, says certified for gasoline engines. On the back, this one is API Service SM, and then next to it is this legend that says API Services SM, SL, and ILSAC GF4, which is another rating. And again, when you go to owner's manuals and things, they may call out either one of these items. Well, then I'm going to go to this one, which is Mobile 1 10W30. It has the API label on it here. This one is for a service SP, and it's an ILSAC GF6A, so it's a more modern one, and it meets API SP, SN+, SN, SM, and typically these are all, it'll usually say, but typically all of these designations are backwards compatible. Whatever the latest one is, it will normally back service. But sometimes they'll put several of them on here to help you. In the fine print here, you'll see a couple of General Motors specs. So you could use this in a General Motors application and it would meet these specifications, and that would work very nicely. However, what you'll see that it doesn't have on here is it doesn't have a Dexos, DEXOS certification. So you have to watch that on a GM engine. The one that does is the one that gets used like in my small block Yukon engine, my 5.3, uses this Mobile 1 0W20, and it's got the starburst on it. It has Dexos 1 approval, Gen 3. They've got various versions of this, but this is what my owner's manual would ask for my 24 Yukon. Then on the back, again, this one is still, it's an SP, just like the other one is. It meets Ford spec, it meets a GM spec, and it's a 0W20. And I think you'll find on the Dexos spec that I don't think it has any 10W30s in it. You have to get in a 0W or a 5W. There's you can go look at the certification list. Now, to throw an odd one, there are special purpose oils. This one is one I use, this Racing 4T 10W40, and then you'd go, hey, I could throw that in my car. Well, no, you don't want to throw this one in your car. This one very specifically is full synthetic 4-cycle motorcycle oil. And you'll see it doesn't have the starburst symbol on the front. It's telling you to use it in cars and gasoline engines. On the back, it's got different, it's an API SN, and it's got JASO specifications, which I believe are the motorcycle ones. And let's see, beyond that, in the description here, it's explaining that it's for motorcycle engines and gearboxes and wet clutches. And so it has things in it that you wouldn't want to put in your car. So that's why its certification is different. Right or wrong, I actually use this in one of my lawnmowers. I use this in a Kawasaki lawn tractor engine. And they prefer 10W40, and my local stores around here usually don't have 10W40 on the shelf. But this one is 10W40. It's synthetic. It covers the whole range. And I made a judgment that, based on what they require from an API level, that it should be sufficient for my tractor. And I've been running it 7 or 8 years. Works really good. And I use that synthetic to cover the temperature range that I might run that lawn tractor through. There are a bunch of other oils that you can use that are available out in the market, but that's just kind of a selection to go along with my explanation. Okay, now let's talk about the variations in the oil a little bit, because I'm going to give you the first one because I broke my own rule for a moment. I've got my 1985 Camaro, and the spec for that was 5W30. And I'm running 10W30. Oops, was I supposed to do that? What's the problem, right? And I'm doing it specifically because I got the engine rebuilt, the cam's got a little different springs on it, a little higher forces. So I'm using VR1 racing oil, which has some additional anti-wear additives, a little bit more zinc in it, and phosphorus in it. to help protect that cam. I did that for break-in primarily when the car was 10,000 miles ago when I've had the engine overhauled. And I've just kept doing it for consistency. And if you look at some of my other videos, you'll see I'm doing oil samples every year, and it helps me to keep that consistent. If I was going to change from the VR1, I'd probably pick a 5W30 in like a Mobil 1 or a Valvoline with a full synthetic, and I think it would work fine even without the extra zinc in it. It just happens that's where I'm running and where it stays right now. But it's for a special purpose, and the reason you use 5W is for cold weather performance, and in the car that I'm running, it's very, very seldom do I ever take it outside when it's below freezing. Usually in the wintertime there's salt on the roads and so forth, and so that car just, I don't have to worry about starting it below zero, so it's not an issue. Other odd things, if you get outside of cars for a minute and you get into small equipment, air-cooled engines are special, right? And they need different things. And again, watch your manufacturer's recommendations. I have a Kawasaki engine in a Husqvarna lawn tractor, garden tractor. And it wants a 10W40 with an SJ rating minimum. And it says you can use that between 14 Fahrenheit and 104, or maybe beyond 104. And I use a synthetic in there. And you've already seen that. It's this 4T racing oil. When I go into my local auto parts stores, nobody uses, 10W40 is kind of a rarity. So I use the so-called motorcycle oil in my small engine because motorcycles are air-cooled. This one's air-cooled. I don't think it hurts anything. It's an SN, so it's past SJ, and I'm good. Now, back in the day, I'll go back to the 80s, I use, and this is still true today actually, but in old school engines like the Briggs & Strattons, Tecumsehs, and so forth, the 4-strokes, I run straight weight 30 in it. And I do that because I had a Briggs & Stratton, and it was a riding garden tractor, 8 horsepower. Not real big, but it worked really hard. And I was down in Indiana in the hot summer, and I scored the pistons, seized it up, got it rebored. I was running 10W30 in it, which the label said I could run 10W30. However, after I got it rebored, I was having trouble starting it. If I had to stop for some reason while it was hot, and I'd go to crank it, it didn't want to crank. It was tight. And I was pretty worried about that. So the one day when it wouldn't crank, I said, I drained the oil right there in the yard and poured 30 weight in and took the 10W30 out. That engine never had a problem cranking in the hot weather again. That 10W30 was running too thin, and in a few minutes I'll explain what that's all about. Now, on the new cars, they've got these 0W specs. Now, the 0W has been around a long time. It was just too expensive for most of us. Again, I'm going to go back to working on tank transmissions in a cold cell. When you were, past -30, there was an oil called an Arctic oil, and it was 0W30 in the 80s. It was 0W30. Now, it still got pretty thick before you got to -65, but it was a synthetic or a semi-synthetic oil, and it works very nicely. And again, I'm going to show you some data why that's nice and not a big deal. Also, the engine manufacturers seem to want to keep ratcheting down the viscosity on the warm side, and most of that's for efficiency, but I think there's more to it than that. And in reading the specs, they went to things like 16 and 12, so they didn't confuse them with the W. So you got, 10W and 15W. And so rather than having a 15 and a 15W, they made it 16. They decided to move by 4s instead of moving by 5s. Kind of an interesting wrinkle, but. And then if you got a diesel, things are different. You've got ratings, API ratings that start with a C normally. And I think there may be some Fs out there, but I don't have a diesel. I haven't had to dig into those too much. Now, so why all these variations, and why are we moving the way we're moving? Well, first of all, oil has gotten a lot better. The advent of synthetic oils and the ability to have synthetic oils and have them affordable has been really great. I'm a fan of them where you need them, right? I would run, well, like today, I'm running the Camaro with the racing oil. That's a conventional, it's not a synthetic. If you keep conventional oils within their bands, they're pretty darn good. I'll add in one. My first experience with synthetic was in manual transmissions, and we were running a test in the lab where we were running with an engine. We were running a transmission in first gear, a transaxle. We were running it in first gear, wide open throttle, trying to see how many minutes it could run before it broke the gears. The goal was like, half an hour or 45 minutes. And we were scoring the gears and then braking them. After they scored, they would develop a stress riser and they'd break. And we were using 5W30 conventional oil. And I went down to the crib, and we had some Mobil 1 down there. And I ended up with a 5W30 Mobil 1 and used it in place of my other 5W30, and the gear scoring just plain went away. And again, data coming. I know, hang on a minute. What happened was, when you got to the high temperatures, when we were running the gears like that, the surface the interface temperature in between the gear teeth gets very hot. And it was probably 350 degrees in there. Might have even been 400. They would get really hot. And the conventional oil was breaking down, but the film strength of the synthetic was holding up. Next thing has been, we keep putting more technology into engines, particularly like cam phasers. We have little, control valves that adjust the cam timing dynamically. We have where we change engine displacement by turning lifters on and off. You got timing chain tensioners in some cases, and fuel economy. But the wide variety of viscosities that you get in oil cause problems. And so the engine teams, they're trying to figure out how to get the viscosity not to change so much. And that's why they tend to go toward synthetics. And then the synthetics have some anti-wear properties because their film strengths tend to be better. So now I'm going to go dig into data. And I had to go back to about 1980, and I had to get out my old machinery's handbook to find the data, because the world and the specifications have changed quite a bit. But in the 1980s and before, older SAE specs, you had 2 points that you measured at. One was 40 degrees C, or about 100 Fahrenheit, and the other was 212, or about 100 C. And those were the 2 points where you measured. So your W oils, your 10W, gets assessed at 100 degrees Fahrenheit. You go, well, that's sure not winter. Well, no, it's not, but it's a little bit, it's a little above room temperature. So if you look at this chart, you've got 10W down here, 20W, then 30 weight, and 40 weight. So this is what a straight 30 weight looks like. My Valvoline, this isn't for Valvoline, this is a generic spec, but that's where you were supposed to run. In centistokes of viscosity, It's like what, about 115, and then down to about what, 5, 6, 7, somewhere down there. Now I'm going to change scales on you just for a minute, so hang with me. Same viscosity, but I went to what's called a logarithmic scale. And the reason I do that is that the oils tend to have a curve to them. Oil viscosity, as you're getting colder, the viscosity goes up like this, almost exponentially up. But it's exponentially as the temperature drops. And so a logarithmic curve scale straightens that curve out, and then it lets me take these numbers at the bottom and spread these apart a little bit. So here's on a log scale, there's your 10W, your 20, your 30, your 40. But these were the goalposts. And so if you wanted a 10W30 oil, let's say, well, 10W40 for the sake of argument. So here's 10W, and over here's 40. So at one end, at 100 degrees, it's 41 centistokes, and at the other end, at 210, it's 14.5 centistokes. Simple mineral oils don't like to do that, so they used chemicals called viscosity improvers to try to make the viscosity better as the oil got cooler. The problem with these specs was that, as I've talked about my air-cooled engine or my gear test, when you got out here to 250 degrees, there's no specification anymore. And so you could have an oil that was here at 41 and drop to, I'll use the 10W30 scale right there, is 30 weight. And then as you went out, it could fall off and lose its strength and drop down and not be good enough when you got out to 250 or 300 degrees, which is a real place where if you're running an engine hard, just depends on the car and the cooling system. Now, if you really want to understand a little better, go to if you have a good oil company that you're going toward, I pulled up, you can go like to Valvoline, and they have product information sheets like I'm showing you here that give you the basics of what their oil meets. This is for a conventional 5W30. And then here are all the specifications for that oil. And I can go to ExxonMobil and Mobil 1, and they'll give me similar charts. And depends on the manufacturer. They don't have to do this. If I just take and summarize the sheets from Valvoline, one of the reasons I picked Valvoline is they have a selection. They do all three, right? They have conventional mineral oils, they have blended synthetic blends, and then they have full synthetics. And so I was able to pick and compare. I used their synthetics and their conventionals. These are the combinations for the oils out of their spec sheets. Now, I'm going to go over and do charts again. This is those same numbers plotted. And so you can see there's the 0W8, 16, 20, 5W30. It's actually kind of interesting. 5W30 and 10W30 actually cross slightly. And then there's the 0W40 and the 10W40. And here you can see how much different a 0W40 and a 10W40 are in performance. But when you're running with your engine hot, this isn't where you're running. You're running down here when your engine's warmed up. And if your engine engineer would really love if these curves were flat across, that they never went up so much when they got cold, because you're trying to feed oil through orifices in the engine into your bearings, into your control valves and switches and so forth, and cam phasers and the like. And you're going from, this one, even the 0W, it's almost 80, and it goes from 10 to 80. It's an 8 times change just between 100 and 200 degrees. And again, I'm going to go back and use the log scale. Just again, makes the curves a little bit flatter and spreads them apart so you can see the difference on a log scale. Well, one more before I go too far. This is just, I picked the 10W40 for a minute, just to recognize that at 212, at 100C, there is a specification range. At 100, they don't publish that anymore, so I was just picking the numbers that the manufacturer provided. But, so this Valvoline 10W40, the SAE spec is it can't be less than 12.5 or more than 16.3. And the actual spec's like 15.7 or something in here in between. But there is always a band, and the manufacturer has to stay within that band. Then, I'll add in is, because of this issue that as I was describing for high temperatures being a problem, they added, and I think this was in the late 80s, early 90s, they added this high temperature, high shear test at 300 degrees with 150C. And you can see all of these oils, 0W16, 0W20, 5W30, they're all pretty close down here, but they all have to pass that. And I would say my old 10W30 that I used in my tractor that scored cylinders, it didn't have to meet that requirement because the requirement didn't exist in those days. Now, I got to add one more thing to the graphs. Boy, I don't want to be too techy because I'm trying to give you information without doing such a deep dive. There are two primary ways to look at viscosity. And earlier I showed you centistokes, and this is centipoise. And centistokes is a measurement of just the viscosity, like if it were running through a hole or running through an orifice and it just ran out. Centipoise is a different type of measurement, and it's designed to assess the viscosity under pressure. So this would be like you're trying to figure out the viscosity when inside a bearing when it's under load. And does it have enough strength? And so what's its apparent viscosity under those kinds of conditions? So when you look at this, these points at 100 and 200 are done off of centistokes. And for the sake of me trying to get you consistent, there's a conversion method mathematically to convert them to centipoise from the density. I went to the spec sheet, got the density, I made the calculation. So everything's in the same units as we go through. Sorry if it's too much, but so these are consistent numbers. But if you go back a few charts and you go look at that point, you'll say, hey, that's not the number you showed me 10 minutes ago. It's the same number, but it's been converted to a different set of units. But you can see again, kind of I'll call it the exponential curve as this comes up. And if I had enough data, we could plot intermediate points and it would be much smoother. I'm just giving you the coarse points to show you the principle. And if I go back to a log so I can spread it out and you can see what's going on here at the bottom, my 2024 Yukon wants 0W20, and look how close that is at 300 degrees, how close that is to a 5W30. But at the far end, down here, then you see them spreading apart because the 0W oil will stay flatter. And the guys on the internet are they're wringing their hands and saying, dang, it's 0W oil, I can't run 0W oil in my engine, it's too thin, it'll ruin it. Well, you're running, so it's 30 or 40 degrees difference to get the same viscosity. It's where the 0W part counts is cold, and your engine will run fine with that viscosity. It's good for it to be thinner when it's down cold. And when you get hot, yes, it's a little less in here, but the engine engineers take that into account. They know how much oil pressure they need. They know what the anti-wear characteristics are. GM runs their Dexos specs, so they know that the anti-wear is within what they consider acceptable. Now I'm going to give you one more, and that is that there are points, and these are all in centipoise again. So we're going to go from, and it's still a log plot, but we're going to go from 300 degrees to 200 degrees to 100 degrees to 30 degrees below zero Fahrenheit. Or this one's 13 below. So 5W30 at 13 below zero, this is like what they added in was, rather than saying a 10W or a 5W oil had to do something at 100 degrees Fahrenheit, they said, no, what I really want is to be able to pump this oil into my engine when it's below zero. And so I want a measurement for the 10W, 5W, 0W that means something when it's brutally cold. And I've done a lot in the brutally cold. Believe me, it's significant. So they pick a number, it's around 6,000 centipoise, and they've got a cold cranking simulator, and they measure the oil, and they produce a data point down here. And so this is like 5W oil stops becoming useful at about 13 below zero, and 0W oil goes to minus 30. That's a big difference. It's a really big difference. And I'll go back to the late 70s when we were having really brutal winters here in the Midwest. And I had a lot of days when I was trying to start my old Mustang up and run it when it was minus 15, even minus 20 or beyond. I think the worst one was a day when it was minus 27. That was a tough deal. But the engine would start up and it would run for 30 seconds with all the lifters banging because it couldn't get oil pressure. It was basically running without oil pressure for 20, 30, 40 seconds. It just, as a driver, it's kind of scary when you just sit there and listen to your engine being noisy. That's what you want. And I was running 10W30 or 40 in those days. That's why you want the zero. You want that oil to flow when it's that cold. And I'm going to go back with my war stories to when I was doing tank transmissions. We had skids for the transmissions to move them around that had drip pans underneath them, and the drip pans always had a half-inch of oil in it, because you'd be putting a transmission on a test stand, you'd take it off, and you'd try to do everything clean, but a lot of times the transmission would leak a little bit, drip something, because you took all these fittings apart. Anyway, our standard oil was 30 weight oil. And, you know, a lot like this 30 weight oil. And I can tell you from being in the cold box, at 30 degrees below zero, straight 30 weight, I literally could walk across the surface of that oil, a puddle of 30 weight oil, without leaving a footprint in it. It was pretty tough stuff. So that's where we're at. Kind of my message, what I'm really trying to say is, first of all, follow the manufacturer's recommendation. I'll say, unless you have some special knowledge that the manufacturer doesn't have and you're building a racing engine, or you've got some special reason, but stay with what they said. 2, don't be afraid of oils just because they say zero on the front end of them. It's a number, it's a spec, but don't let it scare you off. It takes a little getting used to, but that's the way the industry is going, and it's really good for your engine in the long run. So anyway, that's about where I'm going to end for today. There's a whole lot more I could talk about oil. Maybe I'll do that sometime in the future, but this is long enough. So if you liked my video, please like the video, subscribe if you haven't before, support my channel, because hey, that's the way the algorithms bring more people in to see it, is by response from you, the viewer. So thanks for watching again, and that's all for now.